To heat my home, I would need, on average, the same energy as if I were running constantly a vacuum cleaner or boiling a kettle.
Geothermal energy from the ground beneath our feet is an often overlooked way in which we can heat our homes. Just a few meters below the surface, the undisturbed ground temperature is constant throughout the year. This is because it is warmed both by the heat from deep underground and the heat from the sun. This can be accessed through ground source heat pumps and used to efficiently heat our homes.
Solar heat is a really powerful source of energy. However, its capacity to recharge the ground in stored heat is rather limited. On such a typical cloudy day in Edinburgh, in winter or during the night, the ground will lose part of this energy accumulated during the sunny days. This way, it's maintaining a relatively stable temperature over the years.
Rocks are great at storing energy, but the natural warming process from deep underground is actually quite slow. You can imagine the top few hundred metres of the Earth's surface are like a giant heat battery that's on trickle charge. If we take heat out of that too fast, or from ground source heat pumps that are too close together, then we'll reduce the underground temperatures and eventually we'll flatten the battery. Just one home in the UK would need to draw heat from an area approximately the size of not one, not two, but 3 football pitches if we are to ensure that underground temperatures remain undisturbed into the future.
We therefore need to be careful about overexploitation to prevent the current generation using up all the heat. Better still, why not consider heat storage to replenish ground source heat pumps?
Well, have you ever thought about what goes into making a can of Coke? Or instant coffee? Or even the frame of your bike? Or what about where your emails or online photos are stored? Or where the algorithms run that produce your social media feeds and search engine results? Probably not, but industrial processes produce significant amounts of excess heat that at the moment is just vented into the atmosphere, but it actually could be recycled and stored underground for later use.
In an ideal world, we could store this excess heat and transport it to where it's needed. While it's notoriously difficult to transport heat on the surface, the subsurface has a huge capacity to store and transport heat naturally. These natural pathways are enhanced through our industrial legacy. Over a quarter of the UK's population sits above abandoned mineworkings, providing a myriad of pathways and storage opportunities for heat. These multi-level systems could be used to provide cooling and then used to distribute the excess heat regionally to where it's needed. This could be used to enhance the sustainable development of heat pumps.
What you see behind me is part of the central belt of Scotland, typical for many places in the UK. Under most of the settlements you can see and the city you can see, there are near-surface coal mine workings, legacy workings, in which heat can be stored and recycled. And all over this industrial area, there are multiple sources of surface heat which is just being lost to the atmosphere. The GeoBattery Concept provides a fantastic way to recycle the heat and create a sustainable, low-carbon heat society.